Yeah, so what I'm going to be talking about today is syntropic agroforestry. I think it's summed up nicely with the statement on the slide, which is it's learning to farm with the force of nature. And I hope when the lecture is done that we understand this is a paradigm shift from what is typically taught about farming or agriculture. And that's because it's a holistic approach. Instead of focusing solely on a single crop, and then trying to control all of the factors that you think might be able to grow that crop, you're instead focusing on a system that will grow the crop for you. So it's thinking from a bigger perspective, and it has some interesting benefits when you do a holistic practice like this. And I think that one of the most important things to understand is that right now the planet is suffering from a crisis that has to do with destruction of ecosystems. And it's really critical for the survival of humans. We need clean water, we need clean air, and we need good quality fertile soil. All those things are created by ecosystems and forests. And as we're more and more developing different areas, we're losing those important factors for our survival. And most people know now we're dealing with desertification in large areas of the planet. We're dealing with drought and then flood, fire, pollution. And in the end, it's us and our children, the next generation, that are going to suffer from what's happening. What a lot of people don't know is the major role that conventional agriculture is playing in this destruction of ecosystems and the impending crisis. And I think it's important to mention that in this slide because regenerative agriculture requires more investment than conventional agriculture up front, but then it's rewarded later with multiple benefits. So conventional agriculture in a lot of areas, this is a picture from Brazil. It's generally extractive, so the farming comes in, operation comes in, knocks down trees, and then plants. They might start with like cow grazing and then later switch to other crops until they can't farm anymore. In Brazil, it's not a problem because they have so much land, and they just keep moving, destroying new area of forest when the other area is no longer productive. But it's leading to more and more land that's becoming unusable, and it's a problem that that a lot of people aren't aware of. In the Dominican Republic, across the border from Haiti, there's large areas of land that are unusable. They grow thorny bushes, and it's like semi-arid. That used to be their original conventional agriculture sites, but as the nutrition was removed from the soil, it's not farmable anymore. And so they're already experiencing this. And most farmers, even if they don't have to move, they know that as time progresses, they end up having to buy more herbicides. They have to buy more pesticides, more fertilizers to get the same, and sometimes even to get less harvest. And part of the reason we're in this problem is because where we started. So the Green Revolution that started after World War II wasn't focused on how to improve soil fertility or regenerate soil. It was a lot of it was coming from how to repurpose an industry that no longer had a market. So they had an ability to mass produce large machines and mechanized units, and instead of tanks, we have tractors now. Okay. And then also there was a large chemical industry. For example, during the Vietnam War, they were making Agent Orange to defoliate the forest to make it easier for fighting. Once the market is over, then you see it's can be repurposed, different chemicals, but more or less the same. It's coming from the same industry. So in some ways, modern farming is like war. It's war with nature to try to, and it's focused in a very reductionistic way, you know, with this one goal without looking at the consequences on a larger scale. And as we could see from the pictures I've been showing you, if we continue down this path, we're turning soil into dirt, we're turning forest into desert, and it's going to be getting harder and harder to live. And I think those who believe we can just kind of chemically manufacture food will then be faced with the increasing chronic illnesses that we're already experiencing. Nature produces the food in the best way for our bodies. That's a whole nother talk about nutrition and the importance of organic food. So syntropic farming really is a remedy for what we're looking at. And in the last slides, it's a remedy for extractive farming because by definition, it's regenerative. So the most important thing with syntropic farming is that every year your soil fertility is improving. And this image is from Ernest Gouch's cacao farm. I visited his farm a few years ago. I think it was 4 years ago now. And I like to show this because, number one, it looks like a jungle. But number two, to show that he creates this abundance. He's harvesting timber, he's harvesting banana, he's harvesting cacao. It's all in a small, he has a 7-8 hectare area that he manages. And another reason I like to show this picture is some criticism I get sometimes about syntropic is that because it's done in lines, it's not as aesthetically pleasing. This was started with lines, which if you're really dependent on farming for your livelihood, you need to organize and have a structured way to grow things so you can find and manage in a very simple way, and that's how he starts. This still does have lines, but it gets hard to see, and I think it's actually really beautiful, the work he's doing. I have an aerial shot from a drone later will show the same system. So that's just a little introduction. I'm going to shift now into some soil science that when I started learning about syntropics wasn't even available. And what's interesting with this newest science that's been being published in the last years, it really supports what we've been doing and helps me understand why. In the past, I'd be kind of like, it's just magic. You grow the forest, the fertility improves, and we can prove it because the concept has been placed into practice. But now we have science. We have quite a few soil science studies which are helping to explain why syntropic farming works. And so I will present those in the next few slides. And now this is currently the best understanding we have for why it works. But it may be that we have more science that tells us things are slightly different as we move forward. So what this slide shows basically is that even degraded soil that won't grow crops has hidden nutrition inside. And this is a study where they took samples from around the world in both fertile and non-fertile soil, and they did analysis not on the plant available micronutrients but on total nutrients. So normally when you get a soil chemistry study, it's different than this. It's testing just what's available to plants. But what they found when they tested for the total amount is that everything is there. And so the potential is there, it's just locked up. And I use an analogy. In Haiti, we use a lot of visuals, but we always say it's like a baby that's hungry. This would be like your plant that you're trying to plant in infertile soil, and there's food everywhere, but it's just not in a form that can be eaten. So the plant's like surrounded by all these micronutrients and can't consume them. So what Ernst did is he looked for nature for a solution for this. You know, how does nature create fertility? It was like how nature does it is farmers knew to just let it rest. They would leave the land fallow, and back in the day they could let it sit for decades, 70 years. And what happens when the land is bare but left to rest and not disturb it? It becomes forest. And we'll touch on that principle a lot. It's called natural succession. So there's like an intelligence in nature And it always is heading towards forest, because with forest comes fertility. And back in the day, they would cut down the forest after 70 years. They'd come back and they could farm. The farmer wouldn't have to do anything. Just let nature do its thing, and the soil would be restored. And we'll go a little bit into the science by how it does that. And that's just a text describing what we talked about. But if you're following me and you realize, okay, a forest is what's healing the land, it's restoring the soil, then you might have the same question I had, which is, well, what is a forest exactly? How can I use that? How can I use that information on a farm? And I would suggest from my definition of a forest, from the standpoint of syntropic or regenerative farming, is it is in a unified living system. It's all the life forms that are present in a natural jungle or forest. Ernest likes to call it a macroorganism. I don't use that term just because it already has a different definition in the scientific literature, but I think it creates a good visual. You kind of recognize that although there's all these individual members, different trees and plants and insects and other life forms, really they're all working together, and it can be visualized by seeing how they achieve a goal if they're not disturbed, which is improving soil quality. So it's more, a forest is more than just trees growing side by side. You know, the timber factories that we put in the U.S. where it's just a whole bunch of pine, it's not regenerating soil in the same way that a natural forest would. It's missing a lot of elements, and we'll explain more about that later. So in all of the life forms in a forest, I think the most important ones are the ones we cannot see. And those are called microorganisms. There's many different varieties. The two that we'll talk about the most in this lecture is bacteria and fungi, okay, or mycorrhiza. And I'll explain more about those in the coming slides. But the reason these life forms, these invisible soil life, are important is because they unlock all that fertility that I was mentioning earlier. So all those micronutrients that are just sitting there in the soil, the plant can't access them, but they can. So when these microorganisms consume these nutrients, they enter their body. After that point, they're a plant available. So if they die or they defecate, then they're releasing those nutrients back into the soil in a way that the plant can consume them. Okay, so they're like a pathway of fertility. They are the key to unlock what's there. And so then you might wonder, how do I get all these life forms, right? How do I get these microscopic organisms to flourish? What's needed to have a thriving soil community? And if you're thinking that way, then that's great, because a syntropic farmer is basically a microbiology farmer. It's if you're going to focus your holistic practices on one thing, it's to build up the soil life, and they'll grow your plants for you. And so to do that, to grow healthy soil life and microorganisms, you need to understand the relationship that trees and plants have with the soil life. So there's a trade, and both need each other. It's kind of like a marriage. The plants help to protect the soil life. It reduces the temperature. It creates conditions where they hold the water is held in the soil. And maybe the most important thing the plant does is it feeds the microlife sugars. They have plenty of micronutrients and nutrients available in the soil, but what they don't have is sugar. And the plant has excessive amount of sugar because through photosynthesis, through the capture of solar energy, it can create sugar from thin air, basically. It takes carbon dioxide, it can make sugar. So when a plant is hungry for nutrients, what it does is sweat sugars through its roots, and any soil life that might be present around the root zone will eat the sugar. It starts like a feeding frenzy within seconds, And within minutes, the feeding frenzy results in a release of micronutrients through death and defecation from those small soil life, which then is available to the plant. So these plants, if they have the soil life active around them, they can get fertilizer on a moment-to-moment basis within minutes of releasing the sugars, which are called root exudates. They get what they need from micronutrients. Here's a picture in case you wanted to see what this is like. This is a microscopic picture of a root, and there's these tiny filaments. See the big droplets? That's the root exudate. So that's the sugar. You want your plants to be doing that, okay? And there's a way you can know if they're doing it by just with your eyes. And the way you can check is by looking for soil aggregates. Can everybody see the clumps of earth that are on the roots of this wheat plant? Okay, those don't form unless those are formed by the soil life that they make like a glue. And so this is a sign that you have this marriage is successful. The soil life and the roots of the plants are talking, and the symbiotic relationships happening. And aggregates are really important, and I'll show some more images about them in the future for soil health, because they keep the soil on the farm. The glue helps to prevent them from washing away. But all we need to know right now is this is a good visual. If you're not sure if you have good quality regenerative soil, you can pop up one of your plants and see if it has aggregates. Okay? And can everybody see that some of the roots don't have aggregates, these ones at the bottom? So what's interesting, this image is from the Jenna project or Jenna experiment, which was a regenerative pasture experiment, I think in Germany, somewhere in Ireland, somewhere in Europe. And when they did this research study, they thought that to have a good comparison with the control, they needed to give high-dose nitrogen fertilizer, one application to the wheat. And so they did. And what they discovered is when there's excessive amount of nitrogen input, the plant doesn't build aggregates because it doesn't waste its energy to produce soil exudates. You see, it's like it's like if you get junk food to your kids, they're not going to eat dinner. So it doesn't go through its work to get the right healthy nutrients from the soil. But fortunately, they just gave the one application of the high nitrogen, and this is true probably whether it's organic or synthetic fertilizer. If it's high nitrogen, like fresh manure, it's going to potentially cause this problem. If you have mature manure or compost, it's going to be okay. But you can see how it had this effect, and then later without the inputs, then the plant was forced to work for its nitrogen. How many people have heard of leguminous plants are nitrogen fixers? Okay, and how many people are under the understanding that that is the only pathway of nitrogen to naturally get into the soil? That's what I was taught for a long time. And so what's interesting that I learned from Christine Jones is that they've discovered now there are free-living nitrogen bacteria. And what that means is any plant that has aggregates and green leaves is fixing nitrogen. So you don't have to have leguminous plants to get nitrogen. The only difference is in this case the free-living bacteria are not inside the root nodule, they're in the aggregate just outside, but in the end it works for the plant. Leguminous plants are still valuable to include in your systems because of the diversity, and they found that to get the best soil regeneration, it's in this pasture study that you had to have 3 groups represented: grass, leguminous plants, and then like other, which was like flower, herb, and you could have 20 different leguminous plants, and it didn't perform as well if you had just 3 from each of those groups. So that was interesting. And in agroforestry, we often include trees that are leguminous or nitrogen-fixing trees. So I also go for diversity there as well. And so leguminous plants are important, but they're not important because of nitrogen solely. Okay. Then the other organism in soil life that I think we should know about after this lecture is soil fungi or mycorrhiza. And this is an image of a pine tree, a tiny seedling, and people can probably see the roots. They come to about here, okay, the orangish filament. But what's amazing in this image is the amount that the fungi extends the reach of the roots. And so one of the benefits of this association is that it helps bring water to the plant. So soil fungi, it's basically a mushroom. What most people think as a mushroom is just the fruit. And this is actually the plant, if you want to think of it that way, or the organism. And if you have other plants next to it, this connects. So if you have another fungi, a plant next to it, and its fungal associations, they can all connect, and it forms what's kind of like an internet or World Wide Web, but it's the soil. It's called the soil food web. And there's been studies to show when one tree is being stressed or attacked by a pest, it can actually transmit information, and I believe it's actually both through the soil food web and through substances released in the air, so that trees and or plants in the area get that information and they can develop immunity and be protected. So when I think of soil fungi, the two big things I think of is it helps improve immunity, and it also helps with water regulation for the plants. Okay? So both of these things, you don't need any fancy laboratory to know if you have them. You can literally take a shovel and dig into the soil and look for that white filamentous fungi, and you can pull out your plants and look for the aggregates, and you can know if you're heading in the right direction or not. So nature achieves that. So I'm kind of coming back to the first slide when we talked about ancestral farmers used to let the land rest, and then a forest would grow. And what's happening when that forest grows? Imagine all of the microlife that are able to thrive. The more and more developed forest you get, there's more protection, there's more roots. The roots are intermingling, so the microlife are getting different plants associating with them and creating really, really high quality fertile soil. The only problem with natural succession is it's very slow. Depending on the type of forest or the ecosystem you're in, it can be thousands of years. In the U.S., most of them are hundreds of years before they reach maturity. And we don't have time for that as a race. We really need to be able to regenerate soil quicker. And in Haiti, we use a visual that we're recharging a battery when we're talking about the soil and the soil life, because most of this soil that we're coming to, it's somewhere like in this range. It's been extracted for a while. And also we like to use the image of solar panels. So each tree, you can imagine, is absorbing solar energy, and then it's charging the soil battery. And if you had a home with a big roof, would you just put one solar panel here and one over there and struggle to charge your battery, or would you try to fill the roof with every space you have, right? You would do the second. And that's what we're doing in Syntropic. That's why you see these systems that are super dense and plants all filling every little vertical and horizontal space. We're doing that because we're trying to charge this battery and trying to capture every bit of solar energy that we can. This is a before and after from a demonstration in Brazil. On the left, this was grazed by cattle to the point where they really couldn't, they were overgrazing, not managing it very well, and you can see the soil's dry, compacted, very unproductive. They came in and planted a silvopasture system with trees that they can use for fodder, and bananas, which they use a lot for soil regeneration. And then this is probably Mombasa grass. It's a variety of Panicum maximum that's highly productive. And within 2 to 3 years, they're able to bring in the cattle. And I know people are bringing them in. Actually, I know some places that are grazing the cattle while the tree are growing. They're just using solar-powered electric lines to keep them from destroying the trees. So you can literally transition while still using your land. So this is where Ernest's discovery is a game changer, because now we don't have to wait for natural succession. We don't have to separate our farming activities from the forest. He showed us a way to integrate what we want to grow with the forest. And then he showed us a way to speed up the whole, you're cutting and feeding the soil with. And then you have the trees or plants that you're growing for production, right? Syntropic system could be visualized as when you combine those two, when you merge them. And by the way, we'll have, if people didn't know, I'll have PDFs for all of these images that Animeki can send you later. And if you're familiar with how trees grow, and you saw these images I was showing earlier, the first thing you're going to say is, well, how do you grow? You can't grow trees that close together with your crops. It's going to shade, it's going to kill them. So we'll go more into detail in that later, but the short answer is you prune heavily your biomass system. Or Ernest likes to call these mother trees, because they're like the mother caring for the soil. And so it's at least annual pruning of your trees that makes it all happen. And it makes it so that the plants and trees lower down can get the sun that they need. And it's kind of an interesting story how he came about this information. So he knew from the traditional Swiss way of farming to grow in associations. They often grew a lot of diversity in one area. But he didn't know the real heavy pruning technique until a hurricane came, and he had been affected on his farm in Brazil. So he had lots of good associations, higher, taller trees, creating shade for the cacao. And but he wasn't really aware that he should be pruning them real heavy. And so what he was getting was this too overcrowded system. But a hurricane came once and took all of the taller trees down. And that year he had an exceptional harvest of cacao. And he didn't quite put it together, so it had to happen a second time. And another year a hurricane came after the trees had grown back, destroyed them again, and again he had this bumper crop of cacao. And it was after the second time he said, I promised to prune like a hurricane after that. And knowing that it was like good for the system. It wasn't like, sometimes it seems harmful if you're coming through and you're making your trees look like that. You kind of feel bad, but it's, I mean, we choose trees that really like to be pruned like that, and they will grow back strongly. And the whole system, you'll see, it really benefits. So I'm kind of finishing up with this section, this first third of the lecture. And this is going to be a little bit of a foreshadowing for our theory later on. But basically what I hope you've learned is that to build soil fertility, you need dense plantings or a consortium. You need to cut, and then you need to protect the soil or cover. That's going to help create the environment for your soil life to thrive and your fertility.